Alright, in this video I'm going to do some more derivative examples, but ones that are a little more complicated, I suppose, and that use all the ideas, the product rule, quotient rule, chain rule, um, and try to put it all together here. So the first one here is the cube root of 1 plus tangent of x to the fourth. Anytime you're taking a derivative, or an antiderivative for that matter, once you get into that stuff, if and when you do, rewrite your radical as an exponent, and remember, if it's to the if it's a square root, it becomes to the 1/2 power. If it's a cube root, it becomes to the 1/3 power. Alright, so when I look at this problem, I think, well, there's a few things I'm going to have to do to take the derivative. Again, I'm going to have to use the chain rule, starting with the outside. So I'll have 1/3, you leave the inside part alone, 1 plus tangent of x cubed, and we have to take 1 away from the exponent, so we're subtracting 3 over 3, which will give us negative 2/3 as our new power. Then we have to multiply by the derivative of the inside. Remember, the derivative of 1 is 0. The derivative of tangent x is secant squared x, so in the same way, the derivative of tangent is going to be secant squared. We leave the inside part alone. And then we're going to have to do the chain rule one more time, taking the derivative of the x to the third piece, getting 3x squared. And that will be our derivative. You could clean this up a little bit. You could multiply the 1/3 out front by the 3 in the back. Those would simply cancel out and give you a 1. And then there's not really much else you can combine here that I see off the top of my head. I'll pull my x squared out front. I'll pull my secant squared x cubed next, and then I have this negative 2/3 exponent. You can put that back in the denominator as 1 plus tangent x to the third. You could put all that in parentheses, which I'm going to, and make it to the positive 2/3 power, but if we wanted to even rewrite that as a radical, we would put our square outside of the parentheses, and again, it's a cube root. So that would be kind of a cleaned up version with no fractional exponents, no negative exponents as well. Okay. Let's see. Suppose we have the following problem. Suppose we have tangent to the fourth minus 1 cubed times tangent cubed plus 1 to the fourth. So when I see this problem, I think, well, I'm going to have to use the product rule because I see two things being multiplied. I've got a tangent to the fourth minus 1, I've got a tangent cubed plus 1 term. So I'm going to have to use the product rule. I'm also going to have to use the chain rule on each individual piece when I take the derivative. So I'll start with the first factor first. So the chain rule says the 3 will come out front. We leave the inside part alone, take 1 away. Then I have to multiply by the derivative of the inside, the derivative of t to the fourth being 4t to the third. Okay, so that's the derivative of the first part, and we leave the second part alone, t to the third plus 1 to the fourth. And then remember, for the product rule, we put a plus in between there. So now I'll leave my t to the fourth minus 1 to the third power alone, since I took the derivative of that the first time. And then I'll take the derivative of the t cubed plus 1 to the fourth. So the 4 will come out front. I'll have t to the third plus 1 to the third power. And then if I multiply by the derivative of the inside stuff, I'll simply get 3t squared. Okay, so kind of squeezing it all in there. Let me push it up a little bit. You can almost see it all fit in there. At this point, okay, if you wanted to factor this, let's go ahead and clean this up and factor this a little bit. And this is going to be useful down the road when you start finding maximums and minimums for functions.